Law of refraction. What determines the amount of refraction? Well, in the helicopters and submarine activity, you took a ray of light from air into water from your helicopter. Something like this one here. The question is, where did it refract? How do we know where to put it to hit the submarine down below? Which way would it actually refract? Well, to figure those things out, you would need to know a couple of things. First of all, the angle of incidence. Otherwise, once we draw our normal line in here, which is perpendicular to the boundary, at what angle are we aiming our incident ray? So what's theta I? The other factors are the indices of refraction of both mediums. Otherwise, what's the index of refraction for air compared to the index of refraction for water? Here we can call it N for air and N for water. So it's these three factors that are going to determine where this ray of light will end up being in the water. You guys know from experience it'll be something like this, something closer to that normal line. We know it won't go straight through, it'll actually bend towards the normal. Let's see how these factors are related. Snell's law. It turns out that Snell's law relates all these characteristics of the incident medium and the refracted medium together. So if we look at the incident medium, which here is air, its index of refraction and angle of incidence will be related to the refracted medium, water, by water's index of refraction and the angle of refraction in the water. So let's see what these values are. Well, we know that the N for air is 1, hence N1 will equal 1. And we know that the index of refraction for water is 1.33. Let's say this angle right here is about 30 degrees. So let's see how we can put these values in and solve for what our angle of refraction is. So N1 will be air. So this is really going to be the characteristics of the air medium compared to the characteristics of the water medium. So the N for air is 1. The sine of the angle, well, that's 30 degrees. The N for water is 1.33. And here we can see our only unknown is what the angle 2 is, which is going to be our refracted angle. So let's calculate theta 2, the angle of refraction. So the sine of 30 degrees we know is 0.5 if you put it in your calculator. That's going to equal 1.33 times the sine of the angle. Well, 1 times 0.5 is just 0.5. And we have that equals 1.33 times sine of our angle that we're looking for. Well, let's divide both sides by 1.33. So 0.5 divided by 1.33, and of course this side divided by 1.33 is going to give us 0.38 on this side, and that's going to equal not the angle but the sine of the angle. So to undo the sine function we need to take the inverse sine. So in this respect the angle will be equal to the inverse sine to the -1 of the number 0.38. If you do that out on your calculator, as you hear me now, that angle of refraction will be about 22 degrees. Okay, so now we know the factors that will determine how much a light ray will refract. So we're ready for our Snell's law activity, and our goal is to determine the index of refraction for an unknown medium. So in this case it's going to be this block that's right here, this lucite block. And you see we have our old ray box from last week that we used with mirrors. So let's see what we're doing here. We're going to take an incident ray, so that's this ray right here. We're going to aim it right towards that lucite block. So our two media here are actually air, so our light ray starts in air and then it's going to refract once it goes through the lucite. You may have water, this one here is lucite. So we can see that this light ray refracts and then takes this new path when it bends. So in order to figure out what the N value for lucite is, because we know the N for air, we want to measure these angles. So let's draw on our normal line in blue. If you notice this is actually along the 180 zero line on our polar graph paper that we have. And we can label this as our angle of incidence. Let's call it theta 1. And here's our refracted angle, theta 2. We do know the index of refraction for air, and that's 1. So we can write that right here. The N for air, which would be N1, is going to be equal to 1. And we're trying to look for the index of refraction for lucite, which we don't know. So when we go and look at our Snell's law equation right here, okay, we will know what the N1 is for air, so we'll know that. We'll know the angle of incidence, we have that measured, and we will know our angle of refraction right here, theta 2. So what we'll be looking for is N2. What's the index of refraction for lucite or water? Okay, so we'll be all set to do that activity in class tomorrow, and you'll be greatly prepared.